In this video lesson we're going to look at 5 what I call difficult examples of complete the square, and then we're just going to look at some little kind of final issues to do with completing the square at the end. In each case, pause the video, have a go in your own time. I'm going to have a go at this one. Okay, x plus 0.1 because I want half of it, and then I need to minus the square of that thing that's there, plus 0.7, which is x. I'm not bothering to write equal signs at the start. It's partly just because there's space on this little board here. I'm just kind of not in the mood. I think it's really clear what I'm trying to do, so in this case I'm not worrying about it. So that's the first one. There's a theme here. You may think that, and I think, the 0.2 is quite unusual. Often don't see that. But we just plug away with the same method we would anyway. Pause the video for this one if you want. I'm going to have a go. Right. So again, I'm just going to follow my standard method. Yeah, it looks a bit weird, but it doesn't matter. Why did I just rewrite root 5 there? The reason is that root 5 times root 3 makes the root 15, which it would have been, which it will be if you multiplied the bracket back out, which obviously we don't want to. I'm going to leave that gap so I can complete the square inside. X plus root 5, because obviously half of 2 root 5 is just root 5, and then root 5 squared makes 5, so then that'll be, when I multiply it out, that'll be root 3x plus root 5 squared minus 5 root 3. And then I'm going to put my plus 11 here because I like to have the number before the surd, because it means I'm always looking in the same place for surds. I like to have that muscle memory for where to look. I always tend to write things in the same order. I'm going to have a go at the next one. I'm just going to follow my standard method, however unusual the numbers might be. I'm going to complete the square inside. Ooh, so that'd be 0.5. I'm going to use decimal because we've got decimals kicking around here. Minus 0.25 plus 3.9. So then that would be 2.2 x plus 0.5 squared minus, because it's still going to be a minus sign, that would be 0.55 plus 3.9, which is 2.2 x plus 0.5 squared plus 3.35. There we go. Let's try the next one. Again, I'm just going to follow the standard method. X squared plus root, so that would be root 4 root 10, so which is just 2. If you multiply that out, you get root 40. Oh, that's just 10, isn't it? Let's just write 10 to save time. X plus 1 squared minus 1 plus 10. Again, completing the square inside, not doing anything on the outside. I'm going to write plus 10 minus root 10 because again I like to always write things in the same order. My surds tend to go after my whole numbers. It means I can just muscle memory look for them in the same place. Okay, now this is my favourite. We're going to complete the square, we're going to leave it as an equation and rearrange it. You might know what's coming here. If you don't, maybe just watch. So let's complete the square. So it's going to have to be bx over a, because then when you multiply out, the a's cancel. And everything else I'm just keep rewriting around it. So that would be x plus b over 2a squared minus b squared over 4a squared. I'm going to just try and save a bit of time here. I'm going to divide everything by a, so that a ends up there. Excuse me. Right, so what I could do now is I could move some things over to the right hand side. X plus b over 2a squared equals b squared over 4a squared minus c over a. That stays the same, that stays the same. I'm then going to make this into 4ac divided by 4a squared. I did that so that I have it as the same thing underneath. So now I can write x plus b over 2a squared equals b squared minus 4ac divided by 4a squared. So I've combined those fractions, and I just carry on up here. I'm now going to square root both sides. So that means that x plus b over 2a equals plus or minus, yeah, the square root of b squared minus 4ac. Now the square root of 4a squared is 2a. So now we can minus b over 2a from both sides. So we get x equals minus b over 2a. Oh, wait a sec, it's going to be the same thing underneath, so let's save time. We'll combine the fractions straight away. Minus b plus or minus the square root of b squared minus 4ac. Look at that. Interesting. So that's how complete the square can be used to show that equation, which I think probably most of us are familiar with. Let's finish off with some quick kind of questions that relate to complete the square. I often see these mixed in with a complete the square question in an exam. Suppose we drew this as a graph, and it would be shifted -3 and to -4. So it would look like that. What is y's line of symmetry? What is the graph's line of symmetry? Well, that would be the line x equals -3. What is y's minimum value? So the minimum possible value would be if that equals 0, in which case it would be -4. But you can also just tell from the graph, yeah, because that's -4. And let's just label that up as well. So yeah, let's do a bit of labeling. Label your graphs, Duncan. What's the position of the minimum? Well, we can just get that off the graph. Oops. Help if I wrote that in the correct order. So the x coordinate followed by the y coordinate. And what is the tangent at the minimum point? Well, that will be a horizontal line like that with the equation y equals -4. Hopefully that's been some helpful learning for you about complete the square. Thanks for watching.